Hello everyone. Let's continue with our talk about the power. This example talks about variable power. Now, whenever I say variable, that means it's related to time. So the power is changeable. You won't have just a fixed number for it. So here, find the power P of t supplied by the element shown in this figure. So I have some element. It's unknown. I don't know what is it. There's the voltage and the current. Now, as we know, the current goes through the wires. The voltage is put between 2 points. The power of t is the voltage equal 4 cosine 3t. So the voltage source is variable. That means it's related to time. And I of t is sine 3t over 12. Evaluate the power at t equal 0.5, then after half a second, and then at t equal 1 second. Okay, so I'm gonna just use the direct formula for P equal V times I, right? Let me mark the given informations instead of writing them down. So the voltage is 4 cosine 3t, and the current is sine 3t over 12. Right away, since I know P equal V times I, let's multiply those two equations. V, which is 4 cosine 3t, times sine 3t over 12, right? Okay. Before I cancel out any numbers, let me remind you with one formula. It's a useful formula from pre-calculus. This formula says it's the double angle formula. Sine 2 theta equal 2 sine theta cosine theta. So if I have sine times cosine times 2, I can switch it or replace it with sine the double angle. So the angle that I have here is 3t, right? If I use, let's break this 4 to a 2 times 2. So I'm gonna replace the 4 2 times 2, and I'm gonna mark whatever I'm gonna use, this times the 2. So I'm left with 2 over 12, right? 2 over 12 is 1 over 6. You can use your calculator for that, or just uh, divide over 2, so it's 1 over 6. Now the 2 cosine sine part, I'm gonna switch it to sine the double angle. So sine, instead of 3, double the 3, then it's 60. So this is the formula for P of t. When I put it as P of t, that means it's variable. Okay, this is the formula. Now he asked me to find the power at which time, at t equals 0.5 and t equal 1. This is so straightforward. Just at t equal 0.5, plug in for the t 0.5. So P of 0.5 equal 1 over 6 sine 6 times 0.5. Now I want you to pay attention when you enter this equation in the calculator. Always make sure that the calculator on radian. For most part of this class, we will have the calculator as radian, not degrees. So if you don't know how to change it, go on YouTube, or I'm using the Casio version, and it's shift setup and then number 4, it's radian. So if I plug in 1 over 6 times sine the 6 times 0.5, then you will have 0.024. Okay, I approximated it. And the unit for power is watts, right? And then P of 1, that means you just plug in 1. So sine 6 times 1, which is 6. 6 times 1 is 6. So sine 6 The answer is negative 0.046 or 7 if I approximate it. Now just a comment on the power. If the power is negative, that means it's absorbing power at that moment. So this element is absorbing power at the time t equal 1, but it's supplying a power at the time 0.5. Okay, and that's why it's variable, because it changes. You always know that, or you knew that the sign, it goes up and down, up and down. Okay, in this movement. So sometimes it's in positive, sometimes it's negative. Alright, so I will keep you with this for this session. For next session, I'm gonna deal with the sketching part. Now I know that everybody hates sketches, so I'm gonna work on your weaknesses. So see you next time. You have a good one. Bye.